I think most of us, we know each other's work from the social media, from the blogs, and this is an opportunity to dig a bit deeper and maybe somehow contribute and think about possible, I don't really want to say collaboration because that sounds wrong. What I really mean is that we can actually get some feedback from each other on our own work, and that's the most valuable thing that can come out of this meeting. The first speaker, I did something on behalf of Tomáš and myself. Tomáš is closely collaborating with me. He is working on his PhD, he is working on his own, but we have a lot of stuff in common. And I just thought that it is humble to go first. That's not, it's not an expression of just trying to be the first. We knew that probably today at just before 3 and tomorrow at 9 a.m. I think not so many people are going to be here, so that's why I took the liberty to schedule Tomáš and myself, the first speakers. We'll just warm it up here, although it's really cold here. We tried to do something. We are going to figure out what to do with the temperature problem. But when it comes to the atmosphere, we'll try to warm it up at least with our contributions. Tomáš, your turn, exactly 30 minutes. If you are shorter, we can have a Q&A session immediately. If you're longer, I'm going to stop you.
We'll see, because... Thank you very much. Hello, everyone. Welcome. As Jan said, I am doing my PhD in Bratislava at the Faculty of Architecture. The PhD is in the field of digital nonlinear design and fabrication, and in this lecture I would like to somehow sum up the work we have been doing last year and a half, and somehow put it into context of this theoretical agenda, which is the basic agenda of whole MEETUP. So to start, the theoretical scope of generative design is based on deterministic nonlinear ideas of emergence, nonlinearity, and synergy. These theories are a part of theoretical thinkings of, for example, Manuel de Landa, but also many others. This approach is considering all natural but also civilizational phenomena as a result of complex interactions between agents or actors. So basically everything what there is in the world somehow comes out of emergent process. Since it's not only about the nature, but also about the civilization, and architecture, design, and art is a part of civilization, this theory of emergence and generative forces might be considered as a good conceptual background also for a work of architects, designers, and artists. In the nature, the morphology of all living organisms is growing, is determined by its genetic code, and the form, the morphology is developing as a reaction to its background, surrounding. Sorry. Part of architecture and part of design approaches of today are biomimetics, biomimetic approaches. These are actually linear approaches because it is usually connected with some observations and research of some natural phenomena or morphology or structures, and designers or architects are trying to reflect these logic or the structure of some natural phenomena into architecture, into design. This is actually a basic linear way of thinking, because we know at first what we want to achieve. We take a direct inspiration from nature, and we want to achieve that logic, that structure in our designs. The truly morphogenical approach would be different. Truly morphogenical approach would consider as nature or natural phenomena has its powers which are creating them. We should consider our forces which come up of the civilization topics of architecture, topics of design. So we should define these forces and then let them to somehow create the final form. This could become the true morphogenetical approach to design or to architecture, as we say it. So applying these strategies, applying truly or finding a logic which creates a form of architecture and the design, defining it and letting these forces to create the form changes the design process from linear to non-linear. We are changing the top-down strategy to bottom-up strategy when we define the forces, and the forces then create the form itself. And this change from top-down to bottom-up strategy of design may be the biggest chance or biggest challenge of shifting the paradigm of architecture today. As Jan said in the introduction, I think everyone here will be showing the work he's doing, so I would also like this approach I was describing show on some works we have been doing lately. First of the work I have done with Maciej and Jan together is a project Misbehaved. We worked on this project for about last year. It is a project you will be able to see tomorrow after the lectures, and it is a project where each of us created a set or several pieces of jewelry which was created with big emphasis on the creation form or the process of creation. It should be, or we were trying to achieve generative creative process. I was working with Boyd library for Grasshopper, and I used flocking behavior, which is naturally bottom up system. I use these forces in relation with a human body. I use the logics of layering and intersecting the layers, and the final form then appeared as a reaction to digital simulations. the whole structure, the whole shape was created in the digital domain, and then we tried to materialize it into some metal pieces with the metal sintering process. So, yeah, these are just examples of this approach to design in praxis. Sorry. These processes, or this project, the whole design process took place in the digital domain. We were setting up the forces, we were setting up the agents, we were setting up the behavior, and the whole simulation occurred in the digital domain. Then we took the final form and tried to materialize it. This is one way of working with the generative forces in design or architecture, because when speaking of emergent systems and generative systems, generative forces, they are, or the natural way of working with them is simulation. So simulations are very close connected to digital topics. So this is maybe answer to why this is becoming a strong topic of digital approach in architecture. Design, architecture are very much about the materializations of ideas, and in contrast to this project, it's very easy, or it's there is a great potential in a different approach. The material itself, the design process, the fabrication process are very strongly connected with the design itself, and they can become agents of creation of the form. So the process of creation does not occur in the digital domain, but it's somehow transferred into physical. So we set a couple of rules which can be set digitally. We are using a fabrication tool in the physical world. We are using the material in the physical world, and the final design appears as an interaction between these three agents, three elements. So the creation that does not appear in the digital, but in the physical world. This is somehow an idea of nonlinear or emergent fabrication, which is another very great topic, which is very close connected to my PhD. We are working in a structure of these three organizations: rese, Faculty of Architecture of Slovak Technical University, and University of Academy of Performing Arts. Part of our we are collaborating on many levels, but the essential part of this collaboration is a KUKA robotic arm, which are we using in a research experiment, design experiment, and we are trying to find the agency or the morphogenetical power of this fabrication tool, how basically this fabrication tool could become a part of the design process itself. A long-term goal this whole design research is creation of a nonlinear fabrication tool, which would act as a independent tool with its own logic, which would treat the material according its own set of rules, and create the form in the physical world as a generative process. It's a long-term goal. We are working on, until we get to the long-term goal, we are working on smaller scale projects. And we are working on a format of research lab, which many of you know because many of you have been part of these projects or research activities. But for you who don't know, it's a small research project which takes about 2 weeks. It is always proposed and led by one project leader. Now I will be showing you the first research lab which we had together with Mateusz. He was a project leader. I won't be reading all the names because there is always a lot of people collaborating on these projects. The basic topic of the first research lab was creating or merging materials, merging fabrication processes into creating special material or rapid fabrication process with creating a tensile structure, stiffening it with extruded 3D printing, which was precise and precisely defined by or precisely operated with the KUKA robotic arm. Very important part of this research lab was the transition between digital and physical, because we had to work at first in the physical world with setting up the whole setup, then transferring it into physical world, generating a code for a robotic arm for extrusion, then transferring it back into physical and do the actual fabrication thing. This connecting digital and physical world is very important since we are always with these new tools, and this approach of using morphogenetic potentials of materials. It is always necessary to somehow transfer information from physical to digital and back, and set rules which would react or somehow communicate between physical and digital world. The output, yeah, we were trying to stiffen or stiffen the form of curved tensile fabric with plastic fibers. We were doing simulations of forces, and these simulations of forces were used for the actual shapes of stiffening plastic. Second research lab was carried out or proposed by Adrian Krežlik and Kasper Radiszewski. This was more of a material approach to fabrication. We were researching the morphogenical potential of styrofoam blocks. We were treating the styrofoam blocks with heat, and since the styrofoam is heterogeneous material, with treating a piece of styrofoam with the same fabrication process over and over again, you are able to get always different results. As an output of this research project, we wanted to create a installation which was at first the piece of styrofoam was at first treated with the heat to somehow dissolve the material on the places where there was not a structural need for it. And then we were using a wire cutter for cutting out the actual panels of materials to create a whole installation. This was a final result, final installation. Yeah, you can observe many special appearances of styrofoam, which are depending on the process of fabrication. All the tools, all the knowledge base of research lab always stays with the robots. So it is possible for us to somehow continue with investigations of these projects, and it's possible to somehow go deeper into them and use the potential more. The projects are usually very short, so it's not very possible to go deep in the design process to troubleshoot a lot. So we are trying after the research lab to somehow deepen the topic and to work with it more. Great chance for moving this forward or deepening this system is these panels were cut only in linear way. We are doing experiments with curved cuts, and this could also enrich the formal structure of such processes. The last one so far was the research lab with Stuart. It ended an hour ago, maybe. We don't have all the information evaluated, sum up somehow, but this is just to let you know that also today there was a research lab. I want to thank Stuart for a perfect project, and yeah, it was a pleasure to work with you, and we'll go deeper into the thing, and I hope I have not seen the results so far of today, but I think we can with the things we did last week, we can work a lot. So thank you very much. The last collaboration or the last projects I would like to mention to you is a collaboration with Radovan Dranga, who is a photographer. With him, we are investigating the possibilities or the potential of using a robotic arm in the field of photography, field of filmmaking. We had two very interesting projects with him. First was using the robotic arm as a moving tripod. The greatest advantage of such approach is that robotic arm gives big precision, big versatility of movement, and with simulating the paths, we can get very interesting results of photography and filmmaking. The last project, which occurred a week ago, was a performance of robotic development. So we somehow took the traditional analog process of developing a photography, and we wanted to treat it with this fabrication tool. The whole process was completely automatized, and it was a performance for audience. So this is also something how these fabrication tools can be applied in the field of performative art. As a conclusion, I would like to say that the experiments or the research activities that may be considered generative are quite formal so far. It's always about some investigation of some formal approach, investigation of morphogenetical abilities of materials, of tools, but we were not being able yet to somehow use the rules properly for the social or cultural phenomena, to set up the cultural or social agents that could directly bring the morphogenetic of the architecture or of design to new level. But we are doing steps which are necessary to get to the point where the formal approach will be somehow fulfilled, and then we could move on to the maybe deeper topics, deeper themes, and deeper understandings of these generative processes. Thank you for your attention.
I know the things, but because we've been collaborating on most of them, if not all of them. Nevertheless, the reason why we are having these speeches is actually this part where you should start talking to each other, talking to the person who just finished the talk, because that talk is just an introduction to some conversation. So for this moment, I would like you to ask questions, and maybe you can elaborate on some things. We have 10 minutes exactly to do that. In case we are over time, then we are going to stop it again. That's your turn here. Just talk.
Sure, I'll ask something. It's interesting your use of the robot. I mean, the tying the knots and stuff like that's pretty common. But the other stuff with the camera and the kind of using the heat gun and stuff. I'm from SciArc, and so it's nice to see this kind of misuse of the robot. I mean, this kind of industrial machine that, you know, builds cars and everything like this, but you're using a camera on it, you know, like it's a director or something.
Yeah.
It's quite one. Where do you see the dark room thing is actually, I think this is quite great. Just kind of it taking on you're like making this real digital object have a very analog property, which is quite nice. So where do you see the next step on that sort of thing, as I see that you're interested?
Yeah, I think we have to work with the tool as much as we can, as different topics as we can, to see. Maybe we will do next two projects which turn out to be not that interesting, but yeah, it is necessary to just try things and find out what's the potential. And yeah, it's really hard to say. I don't know. I'm curious where we can get with the. We are trying to collaborate with as many people as we can from as many schools and so on.
What was
Sorry?
the knife cutting the cake?
Yeah, it was just the first day introduction of the stewards workshop, and yeah, there were a group of people. Some of us already worked with the robots, some of us not yet. So this was introduction into the basic movement and possibilities, how to set up the code, how to work with it, and sorry.
Was it a timer?
Yeah, but no, I have time until half. Yeah. It was set up wrongly. Yeah, it was just investigation into the work process of the robot. And at the end of the day, we got to eat the cake, so it was nice.
Kuka recipes, you know. This
Yeah. Kuka cutting the cake.
I have more general question. So as I understand, you're interested in behavioral forces to integrate in a digital domain and then stimulate morphogenetic growth or morphogenic forms, etc. So now, of course, like when you like nail digital down, that you say that it comes from Latin digitus or like something like so, that it's actually about like something like counting or like. Always the problem what you have in digital, you see all algorithms, they're about sorting, listing, and so forth, but they're not, in first place, anything, or have this any behavior and so on, like inside of it. So of course, like now, how you transform it actually, or like how you define what is a behavior, so because it's already an abstraction and so on. So, yeah.
Yeah.
What are your constraints? Because I think it's touches like your PhD, which is more generic.
Sorry?
Your PhD topic is more generic about describing like
your
methodology. So I think like it's like a really crucial point. It is like how you actually like put the one into another.
Yeah, I think that it's like two different worlds, the digital and the physical, but when we somehow, when we are observing the natural phenomena as I don't know, I will take the example of flocking because I've used it with the jewelry collection. We were able to observe the morphogenetic or the behavior. We were able to somehow digitalize it. It gets really simple. Those are really simple rules, which are. It is really possible to set them and simulate them also digitally, and there is not a difference between the patterns that are occurring in the real world and the physical world. So I think it's only about setting the behavior or the logic correctly, but it's it's really true that this is very difficult for more complex things, as are, for example, the basic moving relations of a group of birds. So this is where I hope we get to be able to somehow define more complex phenomena with behavior.
Yeah, I mean, when you see it as so, then you cannot say you're just interested in the distribution of points. Like, I mean, you could cut it off completely that you say these are birds, or this has anything, or then you don't have anymore the input side. You just already have a morphogenetic digital, like you completely stay in this abstract.
Yeah.
Because I think like sooner or later this gets really an issue, no? Like what's actually you mean with this behavior? Because mostly like when you remember like the semiological project, which takes like or tries really to mimic or like to address again or reflect back on an existing behavior, let's say. So it's a question like if you're interested in this or just like more about the morphogenetic aspects.
I think, yeah, maybe the morphogenetical, the material basis is, or the tool basis of morphogenesis is like more obvious, but also the questions of semiotics, as you mentioned, might be somehow set as rules or also these approaches develop with the whole society and so on. So I wouldn't say that it is somehow I think it's it's a similar thing to work with all the inputs also with these. I don't know if I understood the question very correctly and if I answered it correctly, but or to your satisfaction. But yeah, we can talk about it later on.
Don't worry about your satisfaction.
Can I have a question? It's related to the same project at least. You mentioned that you try to connect this digital part and physical part, and that mostly includes some sort of a feedback from a physical part to a digital part. And what kind of feedback you were using, or were you using any kind of feedback?
Which project do you mean?
The jewelry project with flocks.
Yeah. We were, as a first constraint, there was a digitally measured and digitally created model of body, and that was somehow digitalized the physical constraint, and then I was layering the flocking agents around it and making various connections and intersection between these layers to find the form. But what is necessary to say here and now, that this whole process of creating the jewelry was the flocking itself. It's a bottom-up way of generating a form, but since I, as a designer of that piece, I was in there and I was evaluating the results and setting up the rules. It's a combination of a top-down strategy and the bottom-up. But I was trying to set with my top-down decisions, I was trying to set the rules in a way that the bottom-up generative process would give me the output which I would be satisfied with.